Hello, everyone. I am Kathleen Labrie. I work at NOIRLab Gemini. I'm based in Hilo, so Gemini North. If we ever get the chance to travel again and you come to Hilo, come see me on the second floor. I'd be happy to talk to you about Gemini data reduction, anything you could need. Uh, First, I would like to give you a bit of an idea of the current status. If you are doing spectroscopy, beware that right now you have to use the Gemini RF package. Dragons does not support spectroscopy. Dragons does support all the imagers. Any of the imagers use Dragons. That being said, we are working on long slit spectroscopy. It's just not ready yet. We're currently focusing on a quick look mode that will be run at night to help with TOO, the Target of Opportunity programs. Those programs need to get the data quickly on sky, but also need to reduce the data quickly to be able to evaluate the source, whether it's an interesting source or not. So that's what we're currently focusing on, but that's basically the foundation of all the spectroscopy that we will do with Dragons. So the next step is to build a science quality long slit spectroscopy suite. And this will add on top of the quick look other more detailed calibrations, some interactive tools that will allow you to fully optimize the reduction. But that's not available now, probably more around 2022. But after that, spectroscopy should start flowing a little bit more with the near infrared and all this. So we're really building the foundation right now. So some resources. First, the installation. We are using Conda to install and distribute Gemini Dragons. So you can install it in a normal Conda environment. All the instructions are on the Gemini webpage. The URL is very, very, very long. So I created a bit.ly for you, bit.ly Gemini Dragons. It will take you to this page. Note that, again, if you're using spectroscopy, you have to use RF. Gemini RF does not work on the newest Mac OS, so Catalina and the new one. So you need to use a virtual machine that we've created here at Gemini that comes with Gemini RF. So go see the site on Read the Docs, Gemini RF VM tutorial, and it will show you how to download, how to install this virtual machine and use it. Now, back fully on Dragons. Our user documentation is on dragons.readthedoc.io. And here, most of you will probably be interested in the tutorials primarily. So we have a list of tutorials for all 5 instruments that do produce image and that are supported in Dragons. So I strongly recommend that you go there, you can download the data, you can run this yourself on your machine. You also have, for those of you who are more interested in the coding aspect or curious, we also have some user manuals and programmers manuals on Astrodata and the recipe system. Recipe system is what Dragons use to automate the reductions. Now I'd like to introduce you to some of the language of Dragons, some key elements that make Dragons work. So to open the files, we use this package that we've created called Astrodata. It opens the FITS file, and once the file is open with Astrodata, it in a way knows about itself. So it will know its fundamental nature, and this is represented by the tags. So it will know I am a GMOS image flat, for example. Those are 3 different tags. So it will know. It's a bit like saying, who am I? So that's what the tags represent. And the tags are used to select the recipes, select the primitives automatically, and to associate calibrations. The other term is the descriptors. So while the tags answer, who am I? The descriptors, they're more, what am I wearing? So it's more the flavor of the data, something like the exposure time, the filter that is being used, the gain, and the binning, things like that. So these the descriptors are used for data reduction and also to associate calibrations. Two other terms are recipes and primitives. So here in the screenshot, I have a recipe, the def make process flat, that's the make process flat recipe. And this is a sequence of steps. Those steps are the primitives. So if you read the recipe, you will read the list of the sequence of primitives, and that should give you an idea of what is being done to your data. Now the details, but it gives you an idea of what is happening. Each recipe is in a file that we call the recipe library, and the recipe library is what gets associated with the data. And at the top of each recipe library, if you were to look at it, it would have this a line like this that would say, well, this recipe library applies to NIRI, image, cal for calibration, and flat. So if the data being fed matches these tags, this recipe will be run. So that's how the magic works. Now to run dragons, on the command line, it's the command reduce. And for many steps, you don't need to add customization or anything. You just type reduce your file list, and off it goes. It does the work for you. If you prefer to code, let's say you have 50 observations exactly identical, you might want to automate that instead of running it on the command line. Well, we also have a Python API, also called reduce, but this is a class. It does essentially the same thing as the command line reduce, just from a program instead of the command line. So typical data flow. I summarize it as 4 steps. We'll go through that in more details, but just the overview is first you need to download your data. So you download the data from archive.gemini.edu. This is where you're going to get all your data and your calibrations. Everything is raw data. And then from that data, you create your file lists, and I strongly recommend that you inspect the data. Once everything is ready, looks good, then you can start reducing your calibration data. So bias, the master bias, the master dark, master flat, and add those process calibrations to the calibration database. Reduce will look in there in that database to find whichever calibration needs. And finally, you're ready to reduce the data. And again, I strongly recommend try the tutorials yourself. The presentation I'm doing here is just a broad overview. Go to the tutorials, run them. You will get a much better sense of dragons doing that. So step 1, download the data. Archive.gemini.edu. If you have a program with Gemini, use the program ID in the form, type search, and you will get all the data that has been acquired for your program. Now, some of the calibrations will be part of the program, but some calibrations are taken at some other time as part of another program. So in order to make sure you have everything, remember to hit the Load Associated Calibrations tab, and it will give you a list of all those other calibrations that you will need. In most cases, it gives you a very, very long list. You don't need all that. So you can choose the ones that you want, usually the ones closer in time to your observations. Remember, all the data in there is raw data. So dragons is what you use to go from raw data to calibrated data. Step 2, sort and inspect. First, the sorting. And by sorting, I mean created your list. So my list of biases, my list of darks, flat, all my H-band science data. It's daunting, it's tedious, but in Dragons, we offer you those 3 tools that really make the task much more pleasant and straightforward. Typewalk will show you the tags for all your files. So it will give you an idea of what type of files you have. Show D is for descriptor. It will show you a descriptor you might be interested in for whichever, all your files or a subset of your files. For example, if I want to see the exposure times for all my files, I would do -D descriptor and the name of the descriptor. Could be filter name as well, or gain, or things like that. And then once you have an idea of the data you have, which list you want to create, you can use data select and set some criteria and send that to a file. In this case, I say, of all the files I have, find all the ones that have the tag flat in them and send that to the file called flat.list. And data select has more ways to really customize your search. If you do the tutorials, you'll see examples of that. And then inspecting the data, I think, is something that everybody should do. Just load DS9, a little display. You can use reduce to do that. So if you do reduce -r, displays as a primitive, and you can look at one file, it will just display one file. In the context of getting ready for reduction, I like to use inspect, and this will loop through the data and add a little pause in between. So currently the default is 2, you can set it yourself, but this will show the first one, 2 seconds, show the other one. And here you don't want to do measurements, you just want to visually make sure that there's nothing really wrong with the data. It happens. So this is something I personally always do with Gemini RF or with Dragons. And we're now ready to reduce some data. We start with the calibrations. The calibrations, to be useful in Dragons, they need to be, Dragons needs to know about them. Once you've created them, Dragons needs to know about them. And to do that, you use a calibration database. It's a very lightweight SQLite database that we provide you. It doesn't contain the data, it just contains information about the data. And that's what Dragons will use. So let's have a look at an example. I want to create a master dark. I have a list of darks. I do reduce darks. And then it will go and reduce the data. It will produce a file with _dark. That's your master dark that you will then add to the calibration database, CalDB, add my master dark. And at that point, Dragons knows about your dark. Same thing for a flat. Reduce the flat, add the flat _flat to the calibration database. And again, at this point, Dragons knows about this dark and this process flat. And you're ready for your science. Again, reduce my list of science. And note here, I don't specify which dark to use. I don't specify which flat to use. Dragons will ask the system, hey, I have this science file. Give me the best dark you have for this, the best flat you have for this, and we'll go fetch it itself. You don't have to specify it. If you wanted to override that selection, you can do it. But in most cases, you really don't have to. And talking about customizations, all of those primitives that you've seen in that recipe, they all have input parameters that can be customized. In order to see those input parameters, we have a tool called show pars, show parameters, plural. And you give the name of the file and the name of the primitives. For example, show pars, name of my file, sky correct, for the primitives sky correct. And it will go say, okay, which version of sky correct matches this type of file. That's why you need to provide the file. And it will give you the list and the default for each of the input parameters. So if you wanted to change that, so reduce your list, -p for parameter, the name of the primitive, sky correct, the name of the input parameter, and the value. And that's how you can customize, and you can put several of them like this. And this is what I have, but feel free to contact me, kathleen.labrie@noirlab.edu, and I'll be more than happy to answer your question related to this presentation. Thank you very much. Have a good meeting.